Welcome to Joys of Code. You know, we all love building data systems that just work. It's a great feeling. But the thing that really separates a pro from an apprentice? It's building systems that survive when things go wrong. So today, we're diving deep into business continuity and disaster recovery, what I like to call the art of designing for failure.
And let's just kick things off with this core idea, right? Building resilient data systems has nothing to do with luck or hoping for the best. It's about intentional, professional design. It's about planning for failure so that when it inevitably happens, it's just a manageable incident, not a full-blown catastrophe.
So let's make this real for a second. What actually happens when a critical data pipeline just breaks or a database goes down? I mean, this isn't just some tech problem, right? It's a huge business problem. To really see what I mean, let's imagine a food delivery company. We'll call them Hungry Now. Okay, so for a company like Hungry Now, if the data stops, the business stops, period. All of a sudden, new orders, they can't be processed. Customers can't track their food, which is a nightmare. Management, well, their fancy performance dashboards are all broken. And maybe worst of all, drivers in restaurants aren't getting paid on time. You see, it's this massive cascading failure that hurts everyone. This is why our job is so incredibly critical.
All right, so here's our game plan for today. We've just seen what happens when the data stops. Next, we're going to dig into the framework for designing against failure. Then, we'll look at the specific tools in our resilience toolkit, we'll build out a continuity playbook, and finally, I'll show you exactly how to prove this impact in your own career. Let's get into it.
So let's jump right into that second point, designing for failure. Look, the professional mindset isn't about trying to prevent every single failure. That's just impossible. It's about designing systems that actually anticipate failure and can handle it gracefully. And this all starts with a few really key concepts.
In the world of apprenticeships, you might hear this called K21. It's basically the formal term for all the strategies and policies we put in place to keep the business running when disaster strikes. For us, as data engineers, it's all about one thing: ensuring the continuous, reliable flow of data.
Okay, our first key metric is RTO, or Recovery Time Objective. This is all about time. It's the promise we make to the business. It answers the question, how fast do we need to get this service back online after it goes down? Is it 15 minutes, an hour, a day? The business helps set that target, and we build to meet it.
And our second key metric is RPO, or Recovery Point Objective. Now, this one is all about data loss. It defines the maximum amount of data the business is willing to lose, measured in time. So think about it. If our last backup was an hour ago, and the database completely dies, we've just lost an hour of data. Is that okay? RPO sets that tolerance level.
And it is absolutely vital you never ever confuse these two. RTO is about service downtime, how fast you can fix it. RPO is about data loss, how much information you literally cannot get back. You could be a hero and get a system back online in 5 minutes, crushing your RTO. But if you lost a whole day's worth of transactions, you've completely failed your RPO. They're different, and they're both critical. So check this out. This table shows how a company like Hungry Now would actually apply this. Just look at the OLTP order system. Super critical, right? It needs a really low RTO of 15 minutes and a tiny RPO of just 5 minutes of data loss. The strategy for that has to be aggressive, like multi-AZ and point-in-time recovery. Now compare that to the data warehouse. The business can live with 24 hours of data loss, so a simple daily snapshot and restore, totally fine, and way cheaper. You see, every component strategy is driven by its business impact.
So, once we've worked with the business to define those RPO and RTO targets, our job as engineers is to make them a reality. And that brings us to our resilience toolkit, the specific technologies we can use and the really important trade-offs they all come with.
A huge part of any DR strategy is choosing your tier. Think of it like this. A hot tier is like having a complete, live copy of your environment ready to go. It gives you almost instant recovery, but man, it is expensive and super complex. On the other end, you have a cold tier. That's basically just restoring from backups. It's cheap, but it could take hours or even days to get back up. The right choice? It always comes back to the RTO we defined for that system.
What's so cool about this is that real resilience isn't about one single magic bullet. It's about layering different controls all across your entire stack. For our streaming data, for instance, we might insist on a replication factor of 3, meaning every single message is safely copied to 3 different brokers. For storage, we could use point-in-time recovery, which lets us literally rewind a database to the exact second before a disaster happened. Even the access layer can pitch in by serving cached data. Every single layer has a role to play.
But listen, tools and tech are only half the battle. When an incident actually happens, at 2 a.m. on a Sunday, you need a plan. You need calm, organized people following a clear, well-understood process. And that is where the playbook comes in. A good disaster recovery runbook is basically your step-by-step guide through the chaos. First, you officially declare the incident and get the right team together. Next, your goal is to stabilize. Maybe that means switching to a read-only mode. Then, you diagnose the root cause, you execute the recovery plan, and then, this is key, you validate that everything is actually working again. And of course, you are communicating clearly throughout the entire process.
And supporting that runbook are these essential elements. You've got to have monitoring that alerts you before your customers do. You need simple checklists. What do we do in the first 5 minutes, the first hour? So that in the heat of the moment, nobody forgets a critical step. And you need a culture that actually practices these plans with drills and game days, and then learns from every incident with blameless postmortems.
So when you put all of this together, the framework, the tools, the process, that is what elevates you. It takes you from someone who just builds pipelines to a true professional engineer. This is how you prove your impact. Seriously, understanding these concepts is a massive differentiator. It shows you don't just build things, you build things to last.
I mean, this right here is the difference in a job interview. The apprentice says, we just rerun the job if it fails. The professional, they talk about a plan. They'll mention specific controls like automated retry logic, rollback scripts, and alert-based triggers. This just screams a deeper understanding of operational excellence. And this all comes down to how you talk about your work. Don't just say, I built a pipeline. Use these powerful I statements that show off your professional mindset. Talk about how you defined RPO targets, how you configured tools specifically for resilience, how you documented the recovery process. This is the exact language that hiring managers and senior engineers are listening for.
So, we'll end on this thought. Failure in our data systems, it's not a possibility, it's an absolute certainty. The only real question is whether you've designed for it. So take these concepts, go apply them to your work, and be ready when it happens. Thanks for watching.